All right, so today, again, we're going to be finishing up Unit 7 with 7.4, and this is going to be real-life applications of how we actually can use quadratics in the real world, okay? So this will make it seem a little more interesting than it already does, hopefully. But the first thing we're going to start off with, it says to find the minimum or the maximum of a quadratic function, okay? So if we think about finding the minimum or the maximum, there's another word for that. It starts with a V, vertex, okay? So we're just finding the vertex on this, okay? So if we look, the very first thing, if a function is in standard form like this, we need to know what A is, what B is. We can write out C, but technically we're not doing quadratic formula on this. We're just going to do that negative B over 2A thing. So we really only need A and B. What is A going to be on this one? 1, yep. So the number in front of the first term. And then what's B going to be? 2, good. So now we are just going to be plugging that in. X equals negative B over 2A. So negative B would be a negative 2 over 2 times 1. 2 times 1 is 2. What is negative 2 divided by 2? Negative 1. Cool. Okay, so we know that the x value of this point is negative 1. How do we know what y is? What do we have to do? Plug it in. Yep. So y is going to equal negative 1 squared plus 2 times negative 1 minus 8. If you don't have a calculator yet, this would be a good time to go get one and type that in for me. Okay, when you plug that in, what'd you get? Negative 9. Did everybody get negative 9? Nobody got anything different? Okay, cool. So, we just found a point. However, we don't know yet if that's a minimum or a maximum. Okay, what we need to do is just look at this A value. Is this positive or negative? Positive, which means it's going to open up or down. Up, so you're saying it's going to have this shape. So the vertex would be right there, which would be a minimum. Good. Okay, so that is how we find the minimum or maximum. It's the same thing as finding the vertex. Okay, so the same process, and we're going to be doing that today, but we're going to be using a different formula. So here is what this formula is. It says it helps us to calculate the height in feet, which is represented by h, of an object shot upwards into the air with an initial velocity of v sub 0 after t seconds. H sub 0 represents the initial height or starting point of the object. Okay, what the heck does that mean? So basically this is a formula that scientists and people all over the world actually do use. So anytime that something is thrown or launched upward in the air, if you think about it, if I threw a ball across this room, isn't it going to have this shape? It's going to go up and it's going to come right back down. It's going to make a quadratic. Okay, so this function here represents exactly that. And so it's always going to start off with negative 16t squared as the first term, okay? And then we sub in the velocity for the next term. So in this case, this isn't it. This is just the formula, so we'll just write that on the blank. So the initial velocity, which is another science term. Okay, and then we've got the height. So, for instance, if I kicked a soccer ball off the ground, okay, what would the height of that soccer ball be from the beginning? It would be 0, okay? So you're going to find that on some of these problems, there's actually not going to be a height because you're starting off the ground. Does that make sense? But if I stood up here on this chair, or if I just threw like a volleyball or something, well, I'm 5'2", okay? So really that ball is being launched from a height, okay? So that would be what we put as that last constant. So we'll go ahead and we will set up an example for this. Okay, volleyball again, whoops. But it says a volleyball was hit straight upwards with a velocity of 176 feet per second from a height of 4 feet. Okay, so we just need to set up the equation. So if we go back, we know that we start with h of t. Our first term is going to be negative 16t squared. My velocity is what? 176, so plus 176t. And then my height is 4. Okay, and be careful on this. Sometimes when you're writing t as a variable, it can be easy to look at it as a plus sign. So I try to make those a little smaller. Okay, so here's our equation. Okay, so this is the first part, is just getting it set up. Okay, the next question, which this is actually a typo on these notes, but I want to know when is the maximum height reached? Okay, that's the first step. So basically what I'm asking you for is the time, okay? This is actually going to be the same as finding the x value of the vertex, okay? So I want you to think about it and write this up in the corner. Normally we have x comma y, right? This is going to be the same thing except for it's time comma height. So time is your x value, h is your y value. Just like the functions we normally have seen would be f of x equals negative 16x squared plus 176x, right? Okay, just sub x's for t's. So that's how this is going to work. So instead of x equals negative b over 2a, this is going to be t equals negative b over 2a. So if I look at this equation, what is my b value? Yep, 176. Remember, A, B, C. Okay, so negative 176 because it's negative b over 2 times what? Negative 16. Good. And now we just solved that. So we've got negative 176 divided by 2 times negative 16, which is negative 32. So type in negative 176 divided by negative 32. Tell me what you got. What'd you get, Rachel? 5.5. Raise your hand if you got 5.5. Cool. If you did not, please wake up, okay? That is the right answer. Anybody type it in their calculator wrong, though? They did type it in and they didn't get that? Okay, cool. So when is the max height reached? It would be 5.5 what? If it's time. Seconds, you got it. Okay. So we found seconds. We found the t value, or in this case, it's similar to the x value, right? So how do you think we would find the height? If we knew x before, how did we find y? Just plug it in. So we're just going to plug in 5.5 for t. So the height at 5.5 is going to equal negative 16 times 5.5 squared plus 176 times 5.5 plus 4. Getting this down, Trevor? Okay, so type that in. Just this part, right? And tell me what you get for the height. $488. Anybody get anything different? All right, cool. 488, and if we had to label it, it would be feet. Good. All right. That is pretty much the gist of what we're doing today. Moving right along, though, we are going to have to graph it. But other than that, that's it. Okay? And there's one more thing on the back, but we'll get there. So the first thing, we've got this equation. It says the quadratic equation is used to find the height of a stone thrown upward from a height of 32 feet at a rate of 128 feet per second. How long will it take for the stone to reach its maximum height, and what is the maximum height? This is what we just did, okay? So the first thing I want you to do is just set up your equation, and then we'll work through this one together. All right, so putting this in our equation, we always start off with h of t equals, our first term is always going to be what? Negative 16t squared. Good. Negative 16t squared. Then comes what? Your velocity, which is which one? Would it be the height of 32 or the rate of 128? The 128. Good. 128t. And then lastly our, the height, which is 32. Okay. We can go ahead and label what our A, our B, and our C are. And now we've got to put this into our formula. T equals negative B over 2A. So how would I plug that in? Say what? Good, negative 128. 2 times negative 16. What is 2 times negative 16? Negative 32. And so I just need to do negative 128 divided by negative 32. T equals 4. Is that what everyone got? Okay. For what? Seconds. So that is our time, or max time. And then lastly, it asks for the max height. Plug it in. So we just do negative 16 times 4 squared plus 128 times 4 plus 32. And tell me what you got. What do we get? Say what? 288. Okay. So what you're telling me here is that this vertex point, or this maximum point, is 288. Okay. So last but not least, we got to graph that. So if we look at this graph that they have given us, we can probably plot the 4, right? We can go over 4, but can we go up 288 on this? Absolutely not. Okay, so what we're going to do is we're just going to change the y-axis only, and we're just going to say that this is in 100s. And I'm just going to write that for now, instead of doing like a key, just because I want to save time. But what I mean by that is if I go up here, this would be 100, 200, 300, 400, 500, and so on. Okay, so if I were to plot 288, I'm going to go over 4, and I'm going to go up between the 2 and the 3, but closer to the 3. Okay. So, since that is my vertex, there is an invisible line that goes through that. Does anybody remember what that's called? Line of symmetry. Good. So I'm actually going to draw that, at least for these first few, just because this is going to help me to visualize here. So, so far all I have is a point, right? I don't actually have a quadratic, even though technically I've given them everything that they've asked me for, okay? But I've got to find 2 more points at least, and then I can just reflect those 2 points over that line, and then I don't have to plug in 4 numbers, right? Because we have to have 5 points total. So if I just find 2, I can reflect them. Okay, so that's what I'm going to do. So what I'm going to do is I'm going to look at this, and I'm going to pick 2 easy numbers on the left. Does not matter what x values I pick. But if I look, I'm already at 4. I'm going to pick, I could pick 0 and 1. I could pick 1 and 2, 2 and 3. 1 and 3, it doesn't matter. Just 2 numbers on the left side of that line. So what do we want to pick? 2 and 0. Perfect. Okay. So what I'm going to do is I'm just going to go back to this, and I'm going to plug in those 2 numbers. And I should already have that in my calculator, so I can just hit the back arrow and just go change all of those 4s to 2s. And that's going to give me this point. And then I'm going to do the same thing, and I'm going to change all of those 2s to 0s. And see what I get there. So when you plug in 2, what do you get? $244? 224, cool. And then what about 0? 32, cool. So now I have 2 more points to plot. So I'm going to go over 2 and then up 224, so a little over the 2 mark. And then I'm going to go on 0 and go up just a little bit. And then I'm just going to do my best to reflect those points over the line. It doesn't have to be 100% perfect, okay, because this, again, is just a sketch. But it should look something like this. And then I just want to connect these points. And here is my quadratic. Okay. So, on the test, if you draw it like this and graph it like that, you'll get your full points, okay? Because that is completely correct. However, if I'm throwing a volleyball, okay, is it going to keep going down below the ground forever? No, it's not. Where's it going to stop? The ground, okay? So, technically, we really don't need to draw this line below the x-axis, okay? Because this is going to stop. But if you draw the lines below, that's fine. Just know that realistically, it's not going to keep going forever. What'd you say? So like the Grand Canyon was below the graph? Yeah, okay. It might tell you that. There might be a Grand Canyon question. Maybe I'll add that. Yeah? Okay, cool. Example 3. I want you guys to work on this one by yourself, okay? I will tell you sometimes, like for instance on this question, it goes ahead and gives you the equation, so you don't have to worry about plugging it in. But I will tell you that this is another typo. I didn't make these notes. This should just be negative 16, whoops, sorry. H of t, not h of x, equals negative 16t squared plus 208t. And we talked about this. If there's no height, what does that probably mean?
They just kicked it off.
Yeah, it's coming off the ground. So that toy rocket's being launched off the ground. Okay, so go ahead and try that one. All right, so what is the first thing we did on this one? So a lot of really good answers. Yep, negative b over 2a is going to give us t. T equals negative b over 2a. What's negative b? Negative 208. And what's 2 times a? Yep, 2 times negative 16 is negative 32. We divide those 2 numbers and we get what? What do we get? 6.5. Good. 6.5 what? Seconds. Now we've got to find the max height. What do we do there? Plug it in. Plug it into what? the equation. So h of 6.5 is going to equal negative 16 times 6.5 squared plus 208 times 6.5.
Plus 0.
Say what?
Plus 0.
Plus 0. You could do plus 0 if you want. What do you get?
676.
676. What? Feet.
Inches.
Not inches. Okay. So then we graph it, right? We go over 6.5. We're going to do the y-axis in 100s again, just because that makes it easy. And we don't have to graph off the page. Okay. Over 6.5 and up to 676. So like right about there. Maybe a little bit closer. Okay. Good deal. Now what? Two numbers to the left. Did you draw your line of symmetry?
Yes.
Yeah, you don't have to do that, but it is helpful. What two numbers did you pick to the left? 4 and 2, 3 and 5. What were your coordinate points that we got? Read me some of them. So if you picked 5 and 640, okay. So that would be right about here. What else? 4 and 576. That works. Okay, again, we're just plugging in any number and then plugging that into the equation, finding the y value, plotting it, and then reflecting it. Okay? Anybody pick anything different? Anybody pick 0? Did you get the point 0, 0 and reflect that? So you could have picked that point, reflected it over. Anybody pick anything different? Okay, this works. So we go ahead and we graph it. And that is it, my friends. How we feel about this? We don't know. It's Tuesday morning. It's bright and early. We feel okay. We just can't feel great yet. Yeah. So what? Oh, that's sweet. Okay. Last but not least, and you're going to be mad at me after this page, but we do have to know how to do this, okay? Oh my. Don't be a brat. Okay, so using our last two examples of a toy rocket and a stone, calculate how long it would take each of them to hit the ground, okay? If we can do well with one problem, we don't have to do both, okay? But I need you to work with me here. They just actually gave me a number in this question here. They told me something. How long would it take each to hit the ground? 0. What's going to be 0 though? The height or the time? The height. Okay, so what they're telling me here is that h of t equals 0. So if I go back and I grab those equations and I bring them back to this page, which one do you want to do? Rocket or stone? Rocket. Okay, go tell me that equation. Read it to me. Plus 0? Okay. Cool. So what they're telling me then is that this is what h of t equals, correct? But they're telling me that h of t is 0. So what I'm actually doing is just setting this whole equation equal to 0 and solving it.
Therefore it's 0.
Say what?
Therefore it's 0.
It's not going to be 0. It's equals to 0, but we've got to solve for t. When does t make this equal 0? Okay, so I honestly think, we can go back to our factoring rules if we wanted to. This one, technically, we could take out a GCF if we wanted to. But quadratic formula is going to be your best bet here. A, B, C. And I know we're sick of this, but we do have to know how to do it. So x, which not x, t is going to equal, in this case, negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So now we're going to plug it in. T equals what? Negative 208 plus or minus 208 squared minus 4 times negative 16 times 0 over 2 times negative 16, which yes is negative 32. Okay, so now we've got to simplify. The first thing we simplify is what we call the determinant, okay? That is what your Delta Math is today. It's going to be kind of a review to get you ready for the test. The determinant is just b squared minus 4 times a times c. It's just what's underneath that radical. So don't type the symbol yet, just type in what's underneath and tell me what you got.
Let's do a squared. Let's just do 208 squared. Everything else is 0.
What do we got? Come on, guys.
Alright, say it, baby. Or I'll say it. Give me your
43,681.
43,681.
416.
Yeah, 416. 416.
It's not gonna be 416. What is it?
43,264.
264?
Yeah, I was saying I ran up the last few numbers because I didn't see them.
Okay.
I just saw the
That's a
43,000.
great plan, Trevor. Okay, 2 times negative 16 is negative 32, we already said. Okay,
432.
so now we've got to simplify this. Go ahead and tell me, what is the square root of 43,264? 208. Cool.
I don't understand.
Okay, so now we've got two different problems here. Okay, two different answers. We need to simplify them. So one of them is going to be addition, one's going to be subtraction. So the first one is negative 208 plus 208 divided by negative 32. And the next one is negative 208 minus 208 divided by negative 32.
That's 416.
Okay, so this first one, type in negative 208 plus 208, hit enter, and then divide that by negative 32 and tell me what you get. 0. So t equals 0. The next one, negative 208 minus 208, hit enter and divide by negative 32.
I'm gonna say it's 12. I have no idea.
13. Okay, good deal. So if we think about this now, all right, the question asked, how long would it take each to hit the ground? So at what amount of seconds would it take it to hit the ground? Well, we know at t equals 0, we've not started yet, right? So we are on the ground. So what's the answer going to be? 13. T equals 13 seconds.
Check it.
Do we want to do the other one, or we feel good about this?
No, we're good.
Yes.
Couldn't you figure that out by just adding the time by 2 or multiplying it by 2?
The time. So multiplying the first